tell you what I was asked. They asked me, they said, Mr. Kramer, we were so excited to go to 10 to the 24th power, which was 100 million light years away from Earth, and we could not believe what we saw. But we even loved it better. And when you went inside the cells, it looked like another universe. We could not believe it. So what I want you guys to think about is this. Today, we are doing that in a way. And what I want you to do is, if you do not have material to work with today, do not worry. Pick up Play-Doh or Model Magic or clay or whatever you have to work with. It should be about as large as what I am working with right now. And I want you to knead it. Oh, that's good, Hayden. And Hayden, change your name to Hayden instead of Catherine. It'll be easier for me. Also, Jesse, change your name to your name instead of Elaine. It'll be easier for me. Thank you so much. Now, guys, I want you to really work this. I want you to hold it. And then I want you to say that you are holding the entire solar system mass. This is the mass of all the planets in our solar system. Now, I'm going to unmute everybody, and we're going to say it together, starting with the planet closest to the sun. Ready, set, go. Mercury, Venus, Earth,
Pluto.
I want to tell you a little bit about the pronunciation of Uranus. Now, this lesson is very difficult sometimes to teach because everybody giggles when they say the word because they say it like Uranus, which is an accepted pronunciation, but that is not Latin. You would never hear anybody speaking Latin and talking about the seventh planet being Uranus. They would say Uranus. And I want you guys to practice this right now. It is Uranus. Go ahead.
Uranus.
You guys did pretty well. Only a few of you got silly, and that's pretty good. Now, what I'm going to do is I'm going to share my screen right now, and I want to show you a picture that got me kind of upset many, many years ago when I saw it for the first time. I looked at this picture and I thought that this is what our solar system looks like. And I maybe thought that for about 10 years. And when I was 10 years old, my 5th grade teacher, Mr. Cunningham, he said, Kramer, that picture you're looking at is a lie. And I'm like, Mr. Cunningham, what do you mean it's a lie? These are the planets. I'm going to be an astronomer. I'm going to be an astronaut. I'm going to the moon. And he goes, Kramer, you can be an astronomer, but you better know the relative size of your planets. And I said, what do you mean? And then he showed me. Are you guys ready to take a journey with me? This is going to be fun.
Mm-hmm.
So what I want you guys to do is this. I want you guys, I'm going to share a screen that I've never shared before. It is a screen of my phone over my head, and you are going to now see in the middle the entire mass of the solar system. So this is 100% of the mass of our solar system, all 9 planets in one. can you please roll this into a cylinder? And when I say cylinder, this is an example of a cylinder. From overhead, it looks like a rectangle. On its end, it looks like a circle. And on the side, it also looks like a rectangle. There are many things made out of cylinders. In fact, I have this tape here. This is a cylinder.
Soda can.
I have my
A cylinder.
antibacteria wipes. That's a beautiful cylinder.
A cylinder.
Yeah. Oh, Maddie, that's awesome. Hey guys, look at this one. This is almost a cylinder. This pen. So I'm kind of a big believer in cylinders. Now watch what I do. I squish it into kind of a longer piece, and then I mash down one of the ends, and look what it looks like. It becomes a circle. Mash down the other end, and another circle. Now start to knead it, like we knead bread. Not N-E-E-D, I think it's K-N-E-E-D, and we knead it. Now I'm making this a little bit wider for me. All right. Now, push down the ends again to make it uniform. And you should have a pretty good cylinder. Anybody have a nice little cylinder here? Now,
Yeah.
you do not need to have a, oh, Omer, yours is perfect. Absolutely perfect. I love it. Now, you are not required to have a ruler today. And the reason is that on page 1 of your packet, Mr. Kramer actually gave you a centimeter millimeter ruler. So if you don't have a ruler, use the ruler that I gave you. Okay?
So it's centimeters?
Somebody has a question, please raise your hand. Go ahead, Hayden.
It's the ruler centimeters, like between 3 and 4 is 1 centimeter?
Exactly right. And remember, guys, this is about the width of a centimeter. If I held up my centimeter, isn't that exactly 1 centimeter, guys? Really, really good. Also, guys, do you remember that this knuckle that I taught you? Remember this knuckle right here? That knuckle is about 2.5 centimeters. So I want you guys to put your ruler up against your cylinders. Now mine is about 11 centimeters. Who can share with me how long their cylinder is? Haley, how long is yours? How long is your cylinder? You'll have to unmute yourself.
I think mine is 10.
Yours is 10. How about yours, Claire?
Mine is 9.5.
Oh, how about yours, Isabella?
Mine is 9.
9. Jackson?
Mine is 10.
10. Ryan?
Mine's 11.
11. Oh, the same as mine. Cool. Kennedy?
Mine is 10.
And Serena?
I don't have any like Play-Doh or anything.
Okay, no worries. What I want you to do, okay, this is what I want you to do. Anybody who doesn't have their material, I would like you, Serena, to actually go like this and simulate what a cylinder would look like overhead and then measure it with the centimeter ruler, okay? So you can do that. Now, everybody, what I want you to do is take your centimeters and multiply it by 10. Omer, what is your centimeters multiplied by 10?
Mine's 120.
Say again?
My of 10 centimeters. So,
So if you multiply it by 10, what do you get?
100.
100 what then, Omer? 100,
120 centimeters.
no, not 120 centimeters.
No, that's what I have.
Millimeters.
Millimeters, yes. Everybody clap. Millimeters are what it's all about. Now, everybody take their knife. Now, by the way, your knife better be a really, really, really safe knife. Now, I'm trying to find mine. Here it is.
You have a knife.
I want you guys, it should be a plastic knife. I also use my ruler sometimes as a knife.
I have
Mark
scissors.
those guys. Mark off every, so for me, I have 110. So I'm gonna mark off every 11. Omer is gonna mark off every 10. Ryan, I think yours is also 11, so you'll mark off every 11. So whatever your centimeters are, you mark off that many millimeters and make 10 equal
Get it.
cuts. Make 10 equal sections. Each section is going to be considered 1/10. Each, by the way, I'm up to 66 right now. Each section is going to be 1/10. And now I'm on 88. I love counting by 11s. And then 99. And then 110. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And guess what, guys? I have split this up into 10 equal pieces. 1, 2,
Like this?
3, 4, 5, 6, 7, 8, 9, and 10. Now,
Like this?
let me see. Oh, yes, Hayden, that's perfect. That's perfect. Now, I want everybody to cut off 6/10. I want you to make a cut, and I'm going to use my ruler because rulers make a really good cut. 1, 2, 3, 4, 5, 6. Now, who can tell me what percentage is on the left side? Remember, this is 6/10. This is 4/10. What percentage is 6/10 of the whole? Everybody say it on 3. 1, 2, 3, go.
60.
60% and then 40%.
Oh,
Yes.
man, that is awesome. Now, guess what, guys? Pick up the 60%. And by the way, I don't even know how you're holding this because you are holding a gaseous planet, the largest planet in our solar system. Everybody make a sphere out of it right now. Go. Make a sphere out of it. And if you
Does
don't,
that mean to pull up the paper that I drew it on since I don't have Play-Doh?
well, you can do it however you want. Just make sure you don't rip up the paper so you have more paper to work with. And by the way, guys, while you're doing this, I want to tell you that some of my students use tofu to do this. Some of my students use hummus. Some of my students use cheese, a wheel of cheese. One of my students went to Italy and she got a wheel of cheese. Oh my gosh, what a brilliant idea. It is so, so cool. All right, everybody have Jupiter? Now, make a little mark on it to make a J. Take your little knife and make a little J, and that is Jupiter. And now on page 1 of your packet, please put it right next to where it says Jupiter. So put it right next to where it says Jupiter. And Serena, you might want to write down the percentage of Jupiter of all the mass of the solar system. So you know it's 60%. And I would write that down if I were you. Now, everybody, we now have 40% left. I want you to pick it up. It represents all 8 of the other planets. And we already have it broken up into quarters. 1 quarter, 2 quarters, 3 quarters, 4 quarters. And what I want you to do is I want you to cut off 1 quarter, please, or 25% of the remaining. So I have just cut off 1 quarter of the remaining, and this is 1/10 of the original. This is 1/10 of the original mass of the solar system. This is 30%.
The solar system. This
Everybody,
is 30%.
who thinks they know what planet this is? Elliot. Louder, Elliot.
Saturn.
Ah, it is Saturn.
Is better.
Wait, are we
Yeah.
making a ball into the 30% out of the 30%?
You are, but guess what?
Out of 30%?
Everybody thought this was Saturn, and it's only part of Saturn.
What? Oh, the
Put it-
ring.
Put it next to Saturn right now.
And
No, not including the rings. This is not the size of Saturn. Put it aside right now.
right now.
Now, I'm
No,
going
no,
to call because there's a little feedback on the line. And I want you guys to pick up the remaining 10%. We are going to be adding to Saturn 2 more times. We are going to be adding to Saturn 2 more times. And here we go. I want you guys now to take this piece. And here's what I want you to do. I want you to make this into another cylinder. And Jack and Serena, if you don't have Play-Doh, draw yourself a smaller cylinder. And then I want you to roll it like this. Make sure you squish the edges so you create uniformity. It should look like a rectangle from up top. It should look like a uniform rectangle no matter where you go. And then let's measure it. Now, I don't want to hear everybody's measurement right now, but I will tell you that mine is 8 centimeters. So mine is 8 centimeters. So I'm going to write that down. 8 centimeters or 80 millimeters. And I am going to cut this into 10 equal pieces. So whatever the number of centimeters you have, that is how many millimeters are going to be each piece. So for me, my first piece is 8 millimeters, 16 millimeters, 24 millimeters, 32 millimeters, 40 millimeters, 48 millimeters, 56 millimeters,
I have a question.
64, I'll be right with you, 64 millimeters, 72 millimeters, and 80, and I have a beautiful set of 10/10ths. Somebody has a question. You may, who is that has a question?
Me.
Hayden,
Hayden?
raise your hand electronically. That way I know that you know how to do that, and it'll be easier next time to get my attention. All right? So Hayden, do you know how to raise your hand electronically?
Yeah, I just did it.
You did it. Okay, great. Now tell me what you have to say.
We're cutting our cylinder into 10 pieces again.
Yes, we are cutting. Well, we're going to mark it into 10 pieces. That's correct. And very, very good. And now what I want you guys to do is this. I want you to cut right down the middle. So you have 5/10 and 5/10. I want you to take either piece and cut 1/5 and then 2/5 and 2/5. So what you should have, and I'm going to write this out for you, you should have 2/5 plus 2/5 plus 1/5 plus 5. Oh, I'm sorry. I made a mistake. And that happens sometimes with fractions. These are 2/10 and 2/10 and 1/10 and 5/10. And I realized my mistake when I got to the 1/2, because I know that 1/2 can't be 5/5. I should have noticed it earlier. Now, here's what I want you guys to do. Are you ready? I want you to take the 5/10. And this is the first piece that you are going to add to Saturn. But what I would like you to do right now is I would like you to make a really long snake. And when I say a long snake, it's really a cylinder, but it's going to be a really long one. And can anybody tell me why I'm making a long snake?
For the rings of
Serena, do not yell it out, please. Serena, please. I'm going to.
Rings for the ring.
Yes. And guys, bring in your Saturn now, please. Measure the diameter of your Saturn right now. The diameter of my Saturn is close to 5 centimeters. Now, can anybody tell me approximately how long my ring cylinder has to be? If the diameter of my sphere is 5 centimeters, how long will the circumference have to be? And you can give me an approximate answer. And Drew, you don't want to keep hitting that chat because then I can't see anybody else's chat. Okay, I'd appreciate that. But if you have a question, ask a great question. And by the way, Sam, you are correct. The universe is, the solar system is a little more than 4.5 billion years old. That is true. Ooh, now Jack said 20. Now, if my diameter is 5, we're going to multiply this by a very special number. Serena said 10. We're going to multiply it by the number pi. Claire, what did you have?
I thought maybe like 20 or 21.
Interesting. Now, guys, who can give me the approximate value of pi? Ben?
3.14159265358979323846246.
And Ben, give me the approximate value of pi. 3 and what fraction?
1/7.
Yes, Ben, everybody, multiply 5 by 3 and a little more. So 5 times 3 is what? Say it out loud. Go.
15.
So guess what? I am looking for something that is 15 centimeters, a little more than 15 centimeters. So yours has to be a little more than 3 times the diameter, and you're going to get the rings of Saturn. Now, guys, mine, I will tell you what it is right now. It's a little more than 15. Are you ready? Here we go. We're going to wrap it around Saturn. And guess what? It almost makes it. It almost makes it. So I'm going to squeeze the rings into Saturn. And I want you guys to do the same thing. Now, what I find really amazing, guys, is that if you look at the rings of Saturn and you look at their diameter, they actually have a larger diameter than Jupiter. Oh my God. Kennedy, yours looks awesome. Can everybody pick up their Saturn and show me? Oh, Claire, yours is awesome. Alexander, amazing. Omer,
This is my closest
cool.
thing to
Isabella, Zach, amazing.
This is the closest
Hayden,
thing I have.
Jack,
A cylinder pencil
awesome.
sharpener.
Awesome. Now,
Mine's just
are you guys ready? Put Saturn down, please, but we're going to be picking it up one more time. Now, I want you guys to pick up these two. They're both 2/10 of what was remaining. Make spheres out of both of them. These two planets are pretty close in size. Isabella, do you know what these planets are?
I don't, but I just I have a question about like what's the percentage of Saturn now?
Ah, very, very, very good question. Right now, guys, Saturn is 35% of the entire solar system. Serena, do you have a question? Or do you want to add? So, Isabella, that was an amazing question. Jupiter is 60%. Saturn is right now 35%. Who knows how many percent is left? Who can tell me? Raise your hand. Serena, go.
5.
Omer, go.
5.
Omer, what do you have?
5%.
5.
5%. Guys, you're holding 2% and 2% of the solar system. What do you think these planets are? Go.
Earth and Venus.
And that would be right,
Uranus and Neptune.
but it's not.
No, it's Venus and
This
Earth.
is Uranus and Neptune. Guys, I want you to listen to this for a second. Are you ready? These planets are each 40 times bigger than the planet Earth. 40 times bigger than the planet Earth. Put them next to Uranus and Neptune on your drawing. And now pick up the remaining 1%. Guys, this is the remaining 1% of the Earth. I'm sorry, of the solar system. This makes up all the other planets, including part of Saturn.
I think
And-
mine's too small.
Well, you know what? It can't be too small because it's relative size. You may not be able to finish this if it's too small. Jackson, yours is about the same size as mine right now. Everybody roll it into a cylinder, please. All right. Here's what I want you to do, guys. Take your ruler. I measure at 45 millimeters. So I am going to cut off a little more than 4 millimeters. I'm going to cut off 1/10 right now. Everybody cut off 1/10. And therefore, what you should have remaining now is you should have 9/10 and 1/10. But remember, this is 9/10 of 1%, 0.9%. This is 0.1%. This is 1/10 of 1% of the solar system. And now, you're not going to be happy about this. This 9/10, pick up Saturn. Put that, smush it into the back or the front of Saturn. Your Saturn is now complete. You will not be picking up Saturn again. Put it down, please. And now pick up the 0.1% of all the mass of the solar system. Make it into a little cylinder, please.
That's okay, I can't believe
And I want you right now, you're not going to believe this. I want you to cut it in half. Now, if you make a mistake, like Mr. Kramer's going to make a mistake on purpose, that is definitely not 1/2. So I am going to smush it back together. It's okay to make mistakes. And guess what? I'm going to cut off half. And we have something very special. Each individual piece is 0.05% of all the mass in our solar system. This is 5/100ths of 1%. Does anybody know what fraction that is? 5/100ths of 1%. So not as a percent, as a fraction, no percent. Does anybody know what that would be? Ben, go for it. You'll have to unmute yourself.
I know it's like 1% divided. It's like 5% of 1%.
Guys, check it out. It's a 5 on top, not hundredths, because that is a percent. 2 more zeros. It is 5/10,000ths. And you can also call that 1 what? Who can simplify that fraction? Zach, can you do that? Can you simplify 5/10,000ths, Zach? I'm going to unmute everybody for just a second. Who can do it? Raise your hand if you can. Raise your hand if you can do it. Ava, Claire, Pete. Pete, I don't see you. And Maisie, I don't see you. Oh, there you are. How about you, Rafa?
10,000.
Oh, wait, it's 5/10,000, but 1 what, Jackson?
1 2,000.
Ah, guess what? Guess what planet is 1 2,000th?
Mercury.
You better hold it carefully. This is the planet on which you live. You live right here, about here, right about there. This is Earth. Put it aside right now.
Why is Earth so small?
And now, guys, pick up the remaining piece. The remaining piece is 1 2,000th. I want you guys now.
We forgot the sun.
Oh, trust me, I did not forget the sun, but we're going to talk about it in just a minute. Are you guys ready? Can you please cut off 1/10 carefully?
Oh,
cut off 1/10,
I cannot do
and I'm going to estimate it.
Cut it into 10 pieces.
So what I have just done, guys, is I went from 1/2000 to
You just need to do 1/10.
1/20,000. This one is 9/20,000.
Mercury.
Add those together, and you get 1/2000. Pretty crazy, right?
Mm-hmm.
Can you please pick up your sister planet?
What?
This is your sister planet.
Mars or Venus?
Her name is Venus. Your sister planet is Venus.
Wait, what?
Venus?
Cousin.
By the way, if you have a question, raise your hand electronically. This Venus is 90% of the mass of the planet Earth. It's very, very close. Serena?
I don't know why it's your sister though.
Well, they're called sister planets because they're very similar in size. They are not similar in their qualities. I will tell you why. You could, if you put lead, you know what lead is, guys? It's a very hard substance. If you put lead on the planet surface of Venus, it would melt. Venus is so hot because of the greenhouse gases. That's why when you hear about the greenhouse gases on planet Earth, people always talk about Venus because Venus is uninhabitable because the ozone layer is so thick, not allowing the sun's heat to escape. By the way, Maddie, that was a very cool background. I like that. Now, everyone pick up the remaining piece. This remaining piece is 1/20,000th of the mass of the solar system. Which planets are left? Say it out loud. Come on. Mercury,
Mars and Pluto.
So everybody make a little cylinder right now. Everybody make a little cylinder. Oh, and Drew, I can't see you either. Make a little cylinder. And can you please cut off 10%?
Venus is right there. Where?
I want you guys to cut off 10%. Now, what we just did, and I'm kind of getting to a point where I almost can't look at these anymore. This piece right now is now 1/200,000 of the solar system mass, and this guy is 9/200,000. And I want you guys to pick up the 9/200,000ths of the solar system, please.
How are we gonna split this into
This is where the person, the inventor, who just sent a rocket into space on Saturday. His name is Elon Musk. He owns SpaceX and he owns Tesla and many other things. He wants us to live on this planet. He believes that we will all be living on the planet Mars. And I almost can't show it to you,
I thought there was no
but
water.
it is 1/10 of the size of the planet Earth. Oh, Hayden, unbelievable. Unbelievable. Now, I want everybody to put that on top of Mars. And by the way, does anybody know why Mars is called the red planet? Can anybody tell us why, please raise your hand electronically if you know why.
It's red.
I'm going to go with Jesse. Go for it. And you'll have to unmute yourself, Jess.
It's probably because it's red. The surface is red.
Yeah, but you got to give me more. You got to give me more there. Hold on a second. Who's speaking?
Me.
Me doesn't help.
Hayden.
Hayden, what were you going to say, honey?
Because it's maybe hot.
Actually, isn't Mars further from the sun than Earth? So Mars is actually colder. Jackson, what do you think?
I think Mars is actually colder, and that's why it's so cold that it's like hot.
Yeah, I think I like what you're saying, but no. Ben, do you have an idea?
What?
I know.
Serena?
Maybe like,
We'll have such good technology.
like it's there's
What do you think we?
forget what a rock it's called, but there's like a red. It's made up of.
Guys, it kind of looks like this. Mars is essentially rusting. It's iron. Iron rusting, lots and lots of iron rusting, and that's what makes it look red. Pretty cool, isn't it? Now, your ideas were wonderful. Your ideas were wonderful. Now, put Mars in its place,
Put it.
and I want you guys to pick up the remaining 1/200,000. Now, you know that this makes up Mercury and Pluto. So I want you to make a cylinder out of it, of course. And I want you to make a cylinder that is 10 centimeters long.
Oh, shit.
I'm kidding. Guys, I'm kidding. I know you can't do that. Mine is about 1 centimeter.
Yeah, roll it
So
up to a
I'm going to cut off 1 millimeter. And by the way, I want to show you,
Good.
remember I told you my pen is about 1 centimeter wide?
Yeah.
And look, guys, I'm going to cut off 1 millimeter.
So I need half of this.
And guess what this millimeter is, guys?
Centimeter. There's 10 centimeters.
This millimeter
No,
is
1 centimeter.
Pluto.
I put it into
10.
This is 10 little
This
pieces.
is 1/2 million.
Half.
This is 1/2 millionth of the mass of the universe. Take Pluto, if you still have Pluto, put it on Pluto, and take the planet, which is 9 times bigger than Pluto.
How?
And this is Mercury. It is the closest to the sun. It's very hot, so don't hold it on your finger for too long. And put your Mercury right where Mercury goes.
So do you see how this is 1 centimeter, which is made up of 10 millimeters?
And we have completed our solar system.
Millimeters.
Now,
10.
I want to show you what this should look like.
So
And I'm going to try to do this, but some of my planets might roll off.
I don't know how.
By the way, do you guys notice that I kind of lost my rings a little bit?
Little.
Saturn. I have Pluto, which is kind of tiny. I have Neptune and Uranus. And
Tom.
who would like to know about the sun?
Me.
Who would like to know about the sun?
Me.
Well, guess what, guys? There's a reason why I left it out.
Why?
If we needed, oh, by the way, guys,
Is the sun a star, not a planet?
No, because he doesn't have enough Play-Doh.
Big.
I want you guys to look at this. First of all, I'm going to show you something here. Hold on a second. New share. Actually, you know what? We'll just stop share. This is a model of the solar system. I put it together yesterday. It took me about an hour, and I hate it. And the reason why I hate it is because it doesn't have any scientific accuracy. It happens to be a lot of fun, though. It glows in the dark, and I actually saw it last night when I walked in the room. It actually glows in the dark. This is the sun. Jupiter is about half the size of the sun. Not true. All the rest of the planet, by the way, this is Pluto. Does that make any sense, guys, that this is
No.
Pluto over here?
Not at all.
No.
No.
This has no basis in reality. Anytime you see a toy, you will not see any basis in reality in that toy. Now I am going to share with you, this is the picture that I argued with Mr. Cunningham about. So Mr. Cunningham and I argued about this picture. I said, yeah, this is what the solar system looks like. And he said, no, it is not. And then he told me that if I were looking at the real solar system, are you guys ready for this? I give you the sun. The sun is actually almost exactly the size of a 75 centimeter diameter exercise ball. Jupiter, which is right here, guys, look at Jupiter in relationship to the
Oh
sun.
my God.
Do any of you have exercise balls that
Yeah.
you can work with?
Yeah.
So what I want to tell you guys is this. If you look at your Jupiter against my exercise ball, oh, Serena, awesome. Jupiter is exactly 1,000 times smaller than the sun. The sun is 1,000 times bigger. If we made this out of Play-Doh, I would have had to ask you to buy 650 tubs of Play-Doh. You would have 650 pounds of Play-Doh, okay, which weighs as much as a heavy motorcycle. You would not be very happy because you would have nowhere to sleep in your house. So I am really glad that I did not want to include the sun in our exercise.
Thank you, Mr. Kramer.
You're welcome. Now,
What about the moon?
now that's a really good question.
The moon's not a
The
planet.
moon, and I'm just trying to think right here. The moon is 1/400th of the, I believe 1/400th of the size of the sun, and the moon and the sun is 400 times further away. So when you look at the moon and the sun, they look to be about the same size, which is really, really cool. Now, I want to share something with you right now. Everybody please go to page 7 in their pack. I'm sorry, page 6 in their packet. Go to page 6 in your packet.
That's the sun.
Now,
I can actually do that.
what I did with page 6, I'm going to show it to you in a little better screen right now.
Perfect like that. Just 'cause I don't have to
Guys, each of these squares are exactly 1 millimeter in width. So these are square square millimeters.
So these are
And if you look at page 5, it shows you the dimensions. 200 millimeters across, or 20 centimeters. 270 millimeters vertically, that's 27 centimeters. And if you multiply 2 times 27, you get 54. Tack on 3 zeros, and you have 54,000 square millimeters. Now, I actually did the math. And I thought, oh, maybe we could do it on a piece of paper. Jupiter is 60%. Saturn, remember Isabella asked that question earlier? Saturn is 35.9% total. Uranus is 2%, and so is Neptune. And this little 2 millimeter square represents 1/1000th of the volume of the rest of the planets, including Mercury, Venus, Earth, Mars, and Pluto. And Earth is half of this.
That's awesome.
So you could not even do it with a piece of paper. It's really, really crazy. Now, the next thing that I want you guys to look at is I want you to look at page 3. Page 3 in your packet shows you that when Earth is 1,
This is big as sun.
when Earth is considered 1, and I'm going to go to a better pen here. If Earth is considered 1, Jupiter is 1,200 times bigger than Earth. Saturn is 718 times bigger than Earth. Pluto is 1/1000 of Earth. So Pluto is to Earth as Earth is to Jupiter and Saturn.
Wait,
As
really?
to Jupiter and Saturn is to the sun. So each and every time we do that, we go up by a factor of 3 powers of 10 of 1,000.
What is he doing?
That is.
It's pretty amazing, guys.
Yeah.
Now, I asked you for the fractions. You can actually do the fractions here. You can do 1.2 million divided by 2 million, or 1,200 divided by 2,000. And you can actually do the math, and the answers are on the next page. So we know that Jupiter is 60% of the mass, but all I did was simplify the fraction. Now look at this one. This one is 718 2,000. That's Saturn. Well, how do we simplify this, guys? Who can tell me what is half of 718? Say it out loud if you know it. On three.
309. Oh, wait, no.
359 over 1,000. So guess what, guys? Didn't I tell you that Saturn was 35.9% of the whole? Neptune and Uranus is 42,000. Come on, help me out, guys. Help me out, come on.
42,000.
Divide by 10, and you get 4 200ths.
So 4,200
Divide by 2, divide by 2.
2 100ths and 1/50th.
And 1/50th, and we know that it is what percent?
2.
It's 2%. And you can actually go and check all the answers on the next page. And it's a lot of fun to do this. Now, here's my last question for you. Of all of these pictures, which do you think is the best representation of the actual solar system?
Which do you think
And Andrew, I'm going to ask you to give me your idea. You have to tell me which row and then which column from left to right. Go for it, Andrew. And I'm trying to unmute you here. Go for it, Andrew.
You kept muting me, unmuting me.
Go for it, buddy.
So I think it's the first row. The first row and the third or fourth picture.
Ooh, I really, really like this one here, but I like one even more. Jesse, what do you get?
I think it's the third row, the second one.
Ooh, this sun is way too small. Kennedy, and then Maddie.
I think it is in the third row, the third picture.
Ooh,
No.
you know what? It's too hard for me to see, so I can't say for sure. Maddie, last one.
Third row, first one.
Ooh, I actually do like this one, but I'm going to tell you my favorite. My favorite one is in the last page of your packet. If you go to this one here, it literally will show you, and I have a picture of my Play-Doh. This is actually as close to accuracy as you will see. Let's go from negative Pluto. Go. Negative Pluto, negative Neptune, negative Uranus, negative Saturn, negative Jupiter, negative Mars, negative Earth, negative Venus, negative Mercury. But don't ever say negative Sun.
Why?
0, 2, 4, 6, 8. Who do we appreciate? Mathletes, go mathletes. Guys, I want you to make many, many solar systems. Send me pictures. Make them out of tofu. Make them out of cheese. Make them out of hummus. Make them out of dirt. Make them out of anything. I don't care. Just have some fun. I'll see you guys soon.